Trust is a key factor of human-robot interactions, linked to task performance and interaction quality. However, most trust measures rely on temporally sparse signals, such as takeover decisions or post-session questionnaires. For robots to consider trust in their behaviors, they would need a real-time, accurate signal. In this article, we show that modeling visual attention, observed through eye gaze, can allow us to extract a real-time signal predictive of human trust. We use data from a collaborative cooking scenario with 49 sessions from 29 participants. In each session, we record the participants' eye gaze, as well as their choices to take over an action from the robot or not, and their answers to validated trust questionnaires. We design a cognitive modeling framework that specifically models two established components of human visual attention: the bottom-up and the top-down components. The bottom-up module models the attention patterns caused only by an image's own features, such as color or intensity. We model it using a convolutional neural network. The top-down module captures the task-oriented influence, and we model it using a visual language model. We combine this with an inhibition of return module that ensures that the predicted gaze does not return to previously visited locations too often, and with a center bias, which captures our natural tendency to focus on the center of our field of view. The resulting fixation is then used in a feedback loop for the top-down module's state estimation. Based on this framework, we run 3 sets of experiments. The first one focuses on gaze prediction, the second one on the connection with trust, and the last one studies the impacts of different bottom-up modules. First, we validate our architecture by evaluating its performance on a gaze prediction task. Using over 250,000 images from the eye-tracking glasses scene camera and their associated ground truth fixations, we show that our framework is capable of predicting gaze better than the bottom-up and top-down components alone. Our second experiment focuses on the connection with trust. We show that the explicit modeling of the top-down and bottom-up components allow us to extract a new signal, which we call the Attention Arbitration Ratio, or AAR. Using Bayesian analysis, we show that the variability of this signal can be used to predict both takeover decisions from the participants and their answers to the trust-related questionnaires. Finally, we investigate how these results are impacted by different modeling choices for the bottom-up component. Using 2 alternatives inspired by visual attention research, we show that using a more realistic model results in worse gaze prediction, but better trust predictive capabilities. Overall, we believe this new trust metric can be a useful tool to estimate trust levels in real time. Thank you for your attention.